Well, in these days, I'm assuming everybody Googled me before the class.
Okay.
How many of you Googled me before the class? Don't lie.
And
I would have Googled you if you guys had a list.
And also, Elaine is the co-instructor of the class. She was in China earlier and she just came back. Yeah. Okay. Okay. So yeah.
Okay.
Let's check.
All right. Thank you. So, like Professor Song mentioned, my name is Jack. I'm currently director of the Application Processor Business Unit at Marvell. How many of you have heard of Marvell? Oh, that's pretty good. All right, more than normal. So we'll get into a little bit about that. One of the things that Marvell is very interested in is in education, and it's kind of been an area of focus, especially for one of our co-founders, Wei Dai, who's my boss. So we'll get into some of that, what we're doing, why we're doing what we're doing. So today I want to talk about some of the background and what we're doing. Really start off with why a digital classroom, why technology can be used, and why everybody's so excited. And then really what we've done in the past year, year and a half in looking at how we can apply technology into the classroom. We found that most of the issues are human challenges, human issues. So we think we have a way to address some of those concerns, and I kind of want to hopefully impart on you guys the requirement that the technology alone is not sufficient, and we have to find a way to use the technology to solve the human problems in order to deploy the technology in the way that maybe we all envision as technologists. Then I'm going to introduce kind of the Classroom 3.0 Smile Plug, which is a new initiative, new ecosystem that Marvell is working on with some partners that we'll get into, and hopefully some of you can be part of that. It's something that's ready to go right now. We're going to do pilot programs of this in India, in the US, in South America, and Africa. So this is not something that's theoretical and on paper, but it's something that's already gone through that stage and is ready to be prototyped and put on the, in a real classroom to see how it goes. So before we get to that, about me, a little bit background. This is the why hopefully you'll listen to me page. I am a Berkeley alum, EECS grad, 2004. I was a TA for CS294, computer architecture, and that's kind of where I really kind of enjoyed the teaching aspect of it. And part of that, I've always been very influenced and very enamored kind of by the education side and how we can make a difference. So there's some personal experience there. I was a TA for 2 semesters, actually helped revamp the course, so worked a lot on course material as well as part of that. And this is a grad class, right? So how many of you guys are also TAs? Currently or in the past? Did they still make you read that book, How Children Fail? Yeah, so that's a great book. I haven't looked at it for like 8 years. Until right before this class, I looked at it again, and I realized, a lot of what I read in that book has kind of influenced how I've viewed education, especially as I look at technology. So if you haven't, I would highly recommend this book if you're really interested in technology and education. How Children Fail. See, I got it in Ned's. I was a engineer, design engineer. I designed circuits, digital design, so that's the CS150 stuff, 152, Verilog things. Did CPU design before kind of moving over to the marketing and sales side. So now I head up the marketing group, the application processor side at Marvell. So what that means, what are application processors? Application processors are the chipsets that go in pretty much every consumer electronic, your phones, your tablets, your e-readers, the point-of-sale terminals, the scanners when you check out. Those things have a little computer inside. Those are application processors. The thing that the FedEx guy has when he scans your package, there's a computer inside. Anything that runs Android. So these days, we're talking about smart appliances. So your refrigerator has an application processor inside. That's processing data. So it really goes in all products. So I do travel quite a bit around the world, visiting customers, seeing what's new in technology. So education is one of the areas that I am very interested in, but on the commercial side, if you will, I'm very involved in all the new technologies. I am also member of the Rio Commission. This is a Washington, D.C. government thing put together. They got a bunch of people from the industry involved. We're supposed to write a report on how technology can be used in education. This report is to be given to Secretary of Education and also the CTO of the U.S. who just resigned. So I don't know if we're going to get a new one, but eventually the report is for President Obama, so we'll see what happens there. And then I'll share some of my experiences and why I think a top-down approach may not necessarily work for technology in education, but nonetheless, we're trying. In education, a lot of the stuff we're doing, some of the things I'm going to show you today are things that we've done in partnership with the Stanford School of Education. It pains me to say that as a Berkeley alum, but that's why I'm here today, so hopefully we can partner with Berkeley as well to do something great together. Also, MIT Media Labs, where the OLPC came from. I have OLPC here. Actually has Marvell inside. Marvell is one of the major sponsors of the OLPC program. So we'll talk a little bit about how that is playing a role and where it may fall short today in education. Yeah, that's my contact thing. Okay. A little bit about Marvell. Represented today. It was founded in 1995 by 3 UC Berkeley grads. This is Sahat Sutarja, the CEO. This is his wife, Wei Li Dai, who's my boss. This is his brother, Pantis Sutarja. So those of you who've walked by that shiny new building called Sutarja Dai Hall is named after these 3 folks right here, in case you didn't know that. Back when I was in school, that was like a pit. It was like chained up, you couldn't go in there. It is the 3rd largest fabless semiconductor company in the world. It's probably one of the largest companies that many people have not heard of. Close to 6,000 employees, $3 billion in revenue. Key markets, just touch on it a little bit just to show you what Marvell is working on, because when we look at education, when we look at these ecosystems, we look at what platforms can we put in there, we're pulling from our technologies in these different areas. And really, even though we're a chip company, an SoC chip company, it's really become a technology company. These technologies are becoming so hard to deploy. There's so much software work that has to be done on top of the chip, on top of making multiple chips work together in a system, that in essence, the semiconductor companies are becoming platform technology companies. What we give to our customers is basically like a phone that's already working. Then they just put some stuff on top and take it to production. So when we talk about some of the prototype things that we can deploy, like if we want to say we want to build a special tablet or we want to build a special phone for education, Marvell's capability to build that whole system. Some of our key markets, mobile and wireless. We're very big in smartphones. We're one of the major suppliers to RIM. Over half the RIM BlackBerries use Marvell full chipset, CPU, modem, everything. Very large in China. The TD-SCDMA, which is the new 3G standard in China. I think there's like 10 million phones shipped last year in the last 2 quarters in China based on that standard, based on Marvell. Wireless, we have a lot of Wi-Fi solutions. We're the Wi-Fi solution in the Xbox, the PSP, and pretty much all your printers. Storage, Marvell got its start in storage hard disk drives. So in every hard disk drive, there's a read channel and a chip. 70% of the world's hard disk drives have a Marvell chip inside. You guys probably all used a Marvell chip before. And this is how the company got started, because Sahat Salva was out there and said, I can make it better. Nobody believed him, and he called them. He claimed he could make it, twice as small, half the power, half the cost. And they're like, okay, do it. And 6 months later, he came back, had a chip. Okay. We won't get into details of that, but it's really, he believed in it. Something, he learned, took his Berkeley background and said, I'm just going to build it and show everybody. Right? And now they're all billionaires. Networking, Marvell is very big in networking. This is fiber optics. This is the big switches, the big Cisco switches that move all the internet traffic around, all based on Marvell solutions. So we're very big in the cloud side. Consumer solutions are tablets, e-readers. We're in the Xbox. We're in the Xbox Connect. That's kind of a pet project of mine that I worked on. So consumer devices. Green technology, LED lighting, smart grid, those areas are being worked on. And of course, print technology. We make chips that go into printers. So your HP printer, your Lexmark printer probably has a Marvell chipset inside doing all the print functions. So pretty much anything you want to build, Marvell can build it. So with that, let's figure out what to build for technology education. Any questions? So as I go through, you guys can interrupt me with any questions, please. So technology is mobile innovations. All this new technology that we've invented in the last few years are creating a whole new set of interaction and possible enhancement possibilities for education. Right? I think that's why people are so excited, because they see all this technology that's applied to every other aspect in our life, but not applied to schools, not applied to the classrooms. Right? We have a picture here. This is, I don't know how old this picture is, maybe let's say the 50s. This is a picture today. This is a picture of, I think, rural India, right? And it's basically all the same, right? Me talking, you guys sitting, except you guys all have computers. But it's fundamentally the same. Nothing has changed, right? In 50 years, the rest of our lives have changed dramatically. We all have, iPhones and Blackberries and these devices. We're always connected. We're always on. And in the classroom, nothing has changed, right? And technology changes really, really rapidly. When I was in school in 2004, this was our bring technology in the classroom. Do you guys still use this? You know what this is? No. Okay. This is a PRS system. I don't know where PR. It stands for Personal Response System. There's like 10 buttons here, and the professor would put like a question up on the board. Every student in the classroom would like type in their answer, and they could see like how people answered, and then they could say, oh well, 70% of people got it right, 30% didn't. Right? This was technology in the classroom at Berkeley in like 2004. Okay, I think Professor Garcia, who guest lectured week 1, he was my lecturer when we used this. So, see how far technology has gone, right?
They're white now.
They're white now? No.
Of course, they're called eye clicker.
Oh.
Eye.
Everything starts with I now,
Yeah.
and it's white. White is more aesthetically pleasing than this.
But the way
Yeah.
you use actually in my class right now with Dave Patterson, we use particular C as well with last spring. And this spring with the London processing side. So we just use old-fashioned just color card.
Old-fashioned color card. So Professor Patterson actually co-taught that class with Garcia when I took it. So that means they've moved back from technology to low-tech paper, right? And this is one of the things I want to talk about today, and we're jumping ahead, but that's okay. One of the most important things that technology is failing to solve is the reliability factor. Right? If it's in the classroom and you're trying to do this and it takes like an extra 10 seconds because this half of the classroom can't shoot the infrared laser over there or something like that happens, technology is not always better. People will revert back to what's easily used. Right? In this case, paper, because paper won't fail. Right? We're going to talk about even here in Silicon Valley. I spent time talking to schools. I go to schools. I went to this private charter school in Palo Alto. Right? This is top 1% of techie in the U.S. You go there. You go, what about technology in the classroom? And they say our internet is down half the time. Right? Our internet is down. We don't know if it's on. Sometimes it's on. Sometimes it's off. So if you ask a teacher to plan a lesson around internet usage, they're not going to do it because it might not work that day, right? And you look at teachers, especially, give you an example, like, elementary school teachers, they have a certain set of curriculum that they have to teach in those 9 weeks or 10 weeks or however long the semester is. So, they've gone through it in the past, so they know I only have 4 days to teach multiplication, right? If I take more than 4 days, then I'm not going to have enough time to teach division and spelling, everything else I have to do. So I have 4 days, and if I waste one of my days messing around the internet, there's no way I can do it. So what are they going to do? They're going to tell everybody to go back, use their pencil, use their paper. Those things are reliable, they're proven. So one of the things that we have to address is reliability for the teachers in the classroom. You have to make it reliable, you have to make them believe it's reliable. Otherwise they will never adopt a solution. Right? They'll just go back to the color papers. Right? You should ask him. This is actually his, I never returned it. It was a pilot program. So kind of, what are we trying to accomplish and why? And why do you think technology can do this? And this is kind of an open forum for you guys. You guys are all, chose to be in this class, right? Why do you think technology in the classroom can be such a benefit?
So for one thing, it provides access to a large pool of online resources that can be pulled on demand.
Okay, so content. You get new content, more content.
A lot of the high quality jobs out there from the schools that grade level kind of require technology.
Okay, so it's let people, by using technology, they'll learn technology because that's a skill that people need to have. Okay.
I think it has potential to enable new ways of learning for a lot of students that might otherwise have disabilities or just a different way of learning than just standard reading a book.
Okay. Individualized learning, right? Different people learn in different ways, so using technology to develop those customized learning solutions.
To include remote students and remote teachers and guest lecturers and so on.
Okay, so the guest lecture part, I guess, is kind of goes to the content side, and then including more people would be, I guess, access, right? Creating more access.
So you can have more kind of interactive lessons and add activities into students.
Okay, so I think the personalized learning part is definitely a key promise of it. Okay.
Technology can be very cheap, so you can design your very complex things. You don't have to print all the posters and details and
Okay. There's the promise that technology will make things cheaper, right? So we'll address if that's true, how close that is to being true. Last one.
I wouldn't know how to explain it, but it seems to be more fun for kids to play with technology than to play with other things. So it might be more interactive and more
Right.
engaging.
Okay. If I don't get to remind, we actually have a case study that kind of showed how that actually did come true, where it interacted students that weren't previously engaged because it was a different format, because they think it's so everything you guys have mentioned, I've heard too in various forms. People think those are the different reasons for why technology can bridge those gaps. I don't think there's no one solution that does all of that, but technology can address them individually, and as that gets built up, I feel like that's when you can kind of have the whole solution. Right? If you try to address everything at once, you often will end up with not addressing anything at all. Finally, last question. Who is this for? So I talked to people about technology education. People have two different views. Some people are thinking third world countries, and we're going to help the people who have to walk 10 miles to school on dirt roads, and then some people say we help the U.S. I mean, where do you think technology can make a bigger difference?
I would bet on the latter. That it's awfully hard to deploy complicated technology in places that don't have a lot of infrastructure.
Okay.
The networks, hardware repair, all these are very specialized needs that we have and that we don't necessarily have in the poorer countries.
Okay. Anybody disagree with him?
I mean, I disagree in the sense that I don't think schools in the U.S. either have people to manage networks. I don't think it's about the poor country. I think over here it seems like we have people who are trained, but I don't think schools in the U.S. also can afford it.
Okay.
I disagree with your choices because it may be the higher education.
Okay. Yep, they usually separate higher education from K through 12.
I'll argue for third world countries, just to make the point. Because U.S. K through 12, we have all these advanced resources, and they're going to use them to use technology to do really advanced things that often don't really work out or help very much. Maybe even very simple use of technology.
Okay. So,
So I actually think it could have more impact on the third world countries in the long run, just from the perspective that their existing resources are considerably more limited than the non-technology resources that were available in the U.S. Like we have extracted public library system and all of this stuff, and they don't really have access to this.
okay. So I'll just take a quick vote, and we'll come back to this because I've got to show you some examples. How many people think it'll be easier to deploy, and by deploy I mean fulfill some of the things we talked about earlier, content, individualized learning, these things. That when I say deploy technology, I mean use technology to enhance those functions. How many think it'll be easier to deploy in third world countries? Okay, 1, 2, 3, 4, 5. How many think it'll be easier to deploy in U.S. K through 12? 1, 2. In the U.S., I guess higher education. Okay. All right. So we got slightly more for the U.S. than the third world. So we'll come back to that. Interesting. Okay. So question: is this technology in the classroom? This is what I think even Obama talked about this just yesterday. He wants to digitize all the textbooks and put it in either an e-reader or a tablet, and they can be preloaded with content to save cost on textbooks. Is this technology in the classroom?
That depends. Not particularly much technology if you take an existing book and just scan it.
Mm-hmm.
That probably wouldn't reduce cost because the production cost of the copy is not with anything.
Mm-hmm. Okay.
I think it all depends on what you're trying to accomplish. I mean, it's technically, in a literal sense, quite technology, but it also depends, if you're trying to make a textbook more accessible to someone who has trouble with the printed format, then that could be the thing that, that student needs themselves just to make the difference. And, it
Right.
might not be for someone else, but for enough students, it really could make a difference.
Okay. All right. So I think you guys are both correct. So it's not about putting content in digital form. It's about what kind of content you put on it and what does this form allow. Whether it allows more access or individualized access or new content like interactive content, multimedia content. So you guys are on the right track, right? Because when you talk about technology in the classroom, it's not just, oh, we're going to drop a PC in the classroom or we're going to drop this preloaded in the classroom. You have to think about how does that affect your content, how does it affect your accessibility. So I would argue that this is the basic minimum, but we should and can do a lot more. Okay. Some of the challenges at a high level, I think there's like some social DNA issues. People have a perception of what education must look like or what it must feel like. Oftentimes that includes somebody who, in theory, knows more talking to other people and maybe not the other way around. So that's a barrier. Resistance to change. People generally don't like to change how they do things, especially if it's working. Reliability issues, we talked a little bit earlier. And finally, the fragmentation side. This is kind of a U.S. K through 12, but also everywhere else. There's so many different school districts, states, different elements. How do you get, you can't just sell once to one place, everybody takes it.
Why is that a challenge and not an opportunity? It seems like it's very much easier to do innovation if you can do it a little at a time, rather than if you have to convince people to turn the entire country's education system upside down.
So I think part of it is true. It's easy to get like pilots done. How do you expand from the pilots? There's issues with content. People are like, this is state-approved content, and this has to be the content. Now, the content here is different than the content there.
That's exactly the opposite of fragmentation, right? There, the problem is there's a centralized authority that says it shall be this, and until you convince the state, you cannot make progress.
And so I would argue that the centralized authorities are fragmented because each state has their own authority, each district has its own authority, and then each principal. It's very fiefdomish, especially in the U.S. They're very reluctant because really if they're all the same, or as we get to like, hey, this technology can be deployed, they're resistant to change because if they're saying, if I'm exactly the same as them, why do I need two administrators? I might be out of a job, right? Rightly or wrongly, people will look after their own personal interests, right? Okay, so let's get into some of the have-nots first before we get to the haves. Okay, the haves and have-nots. That's how I divide the two up. So this is, I believe this is in Gaza. There's no computer, no internet, no library. It's extremely underserved school because of political reasons. Kids have to go through this checkpoint just to go to school. They only get 2 hours of electricity a day. You get 2 hours of electricity a day and you're talking about putting technology in the classroom. What good is all the mobile innovation? Right? All right, so this is, wasn't me that went, it was this study, somebody else went. So they went, they met these students, they asked them to write their own stories. Okay. And they weren't confident in writing, so pretty much they wasted their time, they didn't really write anything. Right? Hardly anybody wrote a paragraph. Then they asked them to tell a story with mobile devices. And everybody's excited, and they came and they lined up to give stories. So this is the I really like this picture because shows them they got their mobile device, they're all excited on it. In the meanwhile, there's this technology that somebody paid good money for that's in the corner of the classroom not being used. Right? This gets into, you can't just put technology in the classroom. People won't just use it just because technology is there. Okay. So breaking down some of the challenges for the have-nots, I guess. This is, content. If you're an underserved school, you don't have much funding. Where are you getting your high-quality content from? Right? Unless you're, so these days, I think that there's an opportunity there with all this online content that's being made available for free. Schools are making it available. Schools like Berkeley, like Stanford, MIT, all have this technology available. Free lectures, it's all there. And the question is, how do you deploy and share the content? Right? How do you get the content from this cloud or wherever it's stored into the hands of those students over there? Right? The infrastructure, electricity is not there. How are you going to deploy mobile devices? Right? On the teachers, teachers in often cases, they have a lack of knowledge with the technology. Right? So the teachers, how do I use it? They don't know how to use it. Right? There's a fear of like, what if we put the technology in classrooms and the students know how to use it better than I know how to use it? That's going to make me look bad. What if my boss comes and asks me to explain what's going on? I don't know, and the students are doing it. He might think I'm not needed. Right? So is technology here to replace me as a teacher? Right? These are real fears that people have. Okay, the OLPC is a good example. This is, it's some people argue it's very successful. Some people argue it's kind of controversial, but they've actually had active deployments in many countries. So I forget which country, maybe it's like Argentina or Honduras or somewhere. Professor went to go visit a classroom that had the OLPCs. And he went in the classroom and all the students were sitting there, they didn't have any OLPCs. He asked the teacher, where are the OLPCs? He's like, oh, they're locked up in the storage room in the back. Like, why are they locked up? Oh, well, we don't want the students to damage them. We don't want them to break them. Right? I don't really know how to use them, so So I was like, well, when are they used? So like, well, once a year, the Department of Education minister shows up, so we take him out, so he can come by, he sees everybody using it, and he goes away, doesn't come back for a year, we lock it up again. Right? But that's what's happened, right? Think about how much effort and money and time went into getting these devices to those students, and it ends up not being used because they didn't address this problem. Challenges for the haves of the world, I guess. Reliability, we talked about this earlier, right? If you only have 50 minutes to teach your class and you can't rely on your internet, you're not going to use the internet. Right? Computer labs. Are there still computer labs in school? Okay, so the problem with the computer lab, this is from my discussions with teachers, is I got to reserve the computer lab, and I got to take the whole class. We got to walk over to the lab. That already takes 5-10 minutes. Then we all get there. Everybody has to log on their different machines. We don't know which ones are working. We don't know which ones are not. People start goofing off. It's kind of maybe more a K-12 problem. People start goofing off, and it kind of doesn't really work. It's more effort than it's worth. Right? So I don't think that has proven to be a solution today. Right? And why are computer labs and not a computer in each student's? Partially was because of cost. Partially was because of control. Right? I think as the costs come down, maybe that goes away. But let's think about the control part, right? The issue is if you put a device in front of every student, and especially talking about younger students, they could be going off. You're afraid they're goofing off. They're going to go browse the web. They're not going to listen to you. They're going to be on Facebook or YouTube or whatever. Social DNA. Teachers who have been teaching for 10, 15, 20 years with the same worksheet. I have this spelling worksheet. I've used it. I know it works. And you want me to use technology, and now I have a whole different way of teaching spelling, or I have a whole different set of words, or it comes in a different order. If you ask them what they really want, they'll say, I might use technology if you had my exact same worksheet in the technology. Right, which it's kind of, well, then what's the point of technology? But at the same token, it's, people are resistant to change. right? So keep that in mind, right? Teachers, finally. Teachers like to be in control of their classroom. You give every student a device, they feel like they're not in control. Right, so we have a solution for that. We'll talk about that. Job security, again. Are you replacing me? Is technology making me not needed, irrelevant? Is it proving that maybe I don't belong and other teachers are more qualified than me? Right? Okay. I want to add one story with the difference between kind of the haves and the have-nots, or the two worlds. So I travel a lot. So I was in China last year. And during this time, right before I went to China, a report was published that said, Shanghai, I think it was Shanghai students score higher on tests. They ranked #1. They finally beat the US. I think this was like a math or something like that. And I was in the US when this happened. So I was reading the US newspaper. And the US newspaper, I was reading on plane, was like, oh yeah, but this doesn't really count because it's only in math and they're still weak in the other stuff. It says, the news article was making reasons why it could be dismissed. Why? Well, it's not really valid because of this, because of this, because of this. And there's these caveats, okay? I go to China, like the next day, so it's also in the news. I'm reading the Chinese newspaper. The Chinese newspaper says, well, we've made this accomplishment, but we're still missing in many areas. This is only math. This is not, these other subjects. It was only like 2 classes, and we need to improve. And it was completely startling how different the viewpoints were. On one side, it was making excuses why this test is not valid. And on the other side was saying, well, this is good, but we have a long way to go. So if you go into, it's a small anecdote, small subset, and certainly doesn't speak for everybody in the US and everybody in China, but mindset matters. Right? If your mindset is, we're the best, we don't need to change, you're not going to change. Eventually somebody's going to pass you. Right? Sometimes being out in front is harder. Okay, if you guys have ever been to, how many of you have ever been to China? Okay, so if you go to like Beijing airport or Shanghai airport, you walk in, how big is that airport? How modern, how nice. It's like 30-foot ceilings and, marble floor. No, it's not marble floors, but, it's a really nice airport. It's really modern, right? If you fly to Washington Dulles, our nation's capital's airport, I don't know how many of you have been there, it's like a dump, right? You go on one terminal, you have to take like this bus to another terminal, and then you got to walk around. So, but in many cases, they got to build their airport from scratch. Right? They got to build their airport from scratch. They didn't have an existing one that they already had investment in. Right? So there's pros and cons to kind of having nothing. In some cases, it's easier to leap ahead, but you don't have as much of a base to work on. Right? Okay, so I want to get to 3 examples of things that have been kind of deployed today, and then get into what we want to deploy in the future. So the first one, a Pocket School and TeacherMate. It's a little tiny device like this, game-based learning for children. The reason why I wanted to highlight this as an example is the reason this has been successful is not because of the device itself. It's a really crappy device. But they invented this case. You can put 6 devices in this case. There's like a USB charger. I don't know, can I, like over here? There's a USB charger in here. So you plug all 6 in, you connect the cable, everything gets charged at once. So this is easy for teachers to use because at the end of the lesson, every student just puts it back in, they close it, there's a lock, it gets charged up, it works the next day. Right? This charging box and this lock have nothing to do with technology. Nothing. But it gets it used. Because now teachers are like, okay, well, it's safe, I won't lose it, I'm not going to get fired because it's lost, I won't forget to charge it. Right? So don't just think about technology, think about these things. OLPC, I already gave the OLPC story of it being locked in the room. But you know, on the good side, they have gotten computing devices in the hands of many, many students around the world, many people. One thing I do want to point out is they use an off-the-shelf server with a school system called XO. And then that acts as their wireless network setup, internet gateway, lets them do backup, lets them do restore, lets them install. The challenges here are still needing an IT guy or somebody to maintain this, right? A server is not cheap, right? You might only have one server per school. You have all these devices, you have like 10 classrooms, they all have devices, and you have one server. So if something happens with this device, I gotta go give it to the IT guy who doesn't exist. And the IT guy who doesn't exist has to go to that one room with the server and hook it up and work. So there's definitely elements here that are necessary, right? These devices in a vacuum, you know, are not as powerful as the devices with a server, right? But how do we get this server into the classroom? Third one, this is a junction server. So this is a program that Stanford School of Education has done, where they have a server, they call it a junction server, running on a PC. There is a router in the classroom. The teacher has a PC of her own. Laptop, this is what they see. They can see all the students, they can see stats and things like that. All the students have their own devices. And today, they've been using phones because they're small, easy to pass around, easy to carry. I think these are Android devices. This is called Junction Quiz. This allows students to write their own quiz applications, share the questions with other students, and students learn from each other. All right, so you write a question, they write a question, and we all share, we try to answer each other's questions. All right, the teacher can see how many people answer the questions correctly, how many people answer differently, you know, maybe you wrote a really difficult question, you know, you wrote a really easy question, you know, we can see the interactivity there. All right, so this has been actually used in pilots, and we can go through the different examples, but this is something that exists today. Right, it's not perfect, right? You still need a laptop, you still need a PC, you still need a router, you know, but the elements are there, right? You have a server in the classroom, right? You have a teacher device that can see the student devices, right? You have students with their own individual devices, right? This could be individualized. As we get to the future, what we like to see is like the teacher should be able to have more control over the student devices, right? Maybe they can tell them all to, you know, if we have digital content here, for example, it'd be nice if the teacher could go, everybody go to page 10, or digitally, everything goes to page 10, right? Or now it's like free time, they can, you know, use the app however they want, right? There's elements of teacher control here that I feel is important in making teachers feel comfortable, right?
Is that like the company Junction Server?
So Junction Server is being built by Stanford. It is open source. We'll talk about this. We believe, okay, wait a minute, and then you'll find out. Any questions on this? Okay. I want to introduce the plug computer. So in order to do that, I need to show a video. Okay. So, 2 years ago.
I think this, well, it says plug computer, right? So it seems to plug into your computer somehow.
Connect your internet to the electrical lab. Is that what it is?
I don't know.
I would say some kind of jack multiplier. That would be my guess.
Is that a chip for a camera or a...
Maybe you charge this against the wall and it's like a mini battery.
What would you say if I told you that was a full computer? I would be very surprised.
It's like a converter. You can plug everything in.
The computer. That's a whole computer.
It is?
What?
This is a computer.
Are you serious?
That's really cool.
So I could
I could program this camera in there. Hey, if you could have a computer that was that small, you could access.
Right, definitely. I'm a student, so I travel between home and school. So I could actually have all my Word documents and all my schoolwork on here. I don't have to, going through airport security, you gotta take your laptop out. Usually your laptop weighs about 8 pounds or something. And this thing could be, a very light, small alternative to that. I could use something like that.
I probably buy it.
Do we get to keep this now that we
Okay. All right, and hold on, one more.
The SharePlug is really unique offering. And it's more than cool, actually. It's revolutionary. It's very simple. It's opening the doors for leading-edge software companies like ourselves to bring new value-add applications and solutions to the home consumer that just aren't possible with today's, with the traditional PC.
High performance, very low power is very important.
It has the right performance, the right form factor, horsepower that we need in order to drive our application.
Thanks to the cooperation with Marvel, we were one of the 12 must-have products of Popular Science magazine of 2009. The combination of these technologies creates a single place, a very small device, which is the center of multimedia at home.
Always on, 24/7 device, which people can leave running all the time, low power consumption, and really enables users to access their information anytime.
Not only is it cool but amazing, but it's really going to redefine and change the way the consumer can now interact with the notion of computing and content and technology that brings it all together in a very small type of device that can do a whole lot.
Okay. Okay, so the plug computer, you guys all know what it is now. Passing one around. It's just 2 years ago. It's basically a full PC and a plug form factor that plugs in the wall. So the original one, which is the smallest one there, had one USB port and one Ethernet port coming out of it. I think it's basically this one. Further iterations of them, we've added more things. Some of them can have multiple USB ports. Some of them have built-in hard disk drives for storage. This one, for example, has a HDMI out plus like an SD card in. So the concept was designed, how small can we make it, how low power can we make it? And then people have deployed it in different forms with different types of peripherals. Okay. So I'll pass these around too, I guess.
So how do you compare the power outputting versus a phone today?
Processing power or?
Both, everything.
Yeah.
Everything.
So processing power, so there's different versions of the plug computer depending on different chips that we put inside. But generally for server type functions, it outperforms your devices. We have a 2 gigahertz CPU in here. Your phones are still probably 1 gigahertz, some maybe 1.2 these days. It has a richer peripheral set for PC type computing. For multimedia functions, it really depends, but these devices are looking more and more similar. Your phones are becoming more and more powerful like your PC. These chips are becoming more and more like servers. So in general, these will have higher performance in your phones because it's still plugged in. It's still your server device as opposed to your mobile device. So it depends on your device. So you can put flash in there. You can put external USB. You can put a hard drive. So some of them have been deployed with hard drives. Some of them deployed very cheaply, no storage. Just use a USB stick. So that depends on your implementation. Oh, there is a small NAND boot. It boots Linux. Yeah.
And also, given that the thing is designed to plug into the wall, the power consumption is less important than the power consumption.
Correct. But it's still designed to be 1 watt, 1 or 2 watts of power compared to your PC servers, which is taking hundreds of watts. Right? So now, if you're only taking 1 or 2 watts, you can use this. You can put a battery in it. You can use solar power. You can use motorcycle batteries. Okay, we'll just jump ahead. Here. This helps solve the power problem. This is a solar power panel in Rwanda powering the plug. Real life, deployed. Right? This is, I believe, a motorcycle battery, and probably very dangerous. Motorcycle battery charging the plug. Right? So, putting a battery in there as an option for backup when reliability fails could be an option. So this is, so again, a lot of these details are implementation specific, what you want to put in your plug computer, but as a concept, we think it solves many problems, right, this being one of them.
Okay. Let me be the first to say I am confused because I do not understand what good it is without a screen.
That's a server, right?
It's a
I
server.
don't want a server in my house. There's a server in the cloud that costs half as much. Like the premise
just
that I want a server in my own house is nuts, right? Because like everything I ever care about is online.
Yeah, but you have reliable internet access.
But if I didn't have reliable internet access, I wouldn't want a server, right? The premise of
So-
the server is that it can connect to stuff.
Well, so the premise here, okay, where's
Yeah,
your
well, tell us about use cases.
Yeah, so use cases, right? Solve the content problem with the plug. How do we get content to these classrooms? You load the content onto your plug, and now you have a content server, right? You have your books, you have your video, you have access. It can be online or offline, right? This creates a micro cloud in the classroom. So in the classroom, it's reliably always connected to this product, right? It may or may not be connected to the main cloud outside, but as long as you get some connection once in a while, you can update this device. You can get new content, right? Once a week, you can download new content for the next week, or once a year, right?
Yeah, and I've seen work on search engines for developing world where people queue up their queries so that when there is connectivity, you go and download a whole lot of stuff in very smart, express ways and have them on there.
Yeah, we talk about concepts where the rural villages can have this, and once a week or once a month, they can go back to the main village and get it connected, get it updated, right? And it's not just data from here as a content server, but it's data back, right? You can take students' data, they're doing their homework or tests or whatever assignments, that data that they're doing can be collected here and be sent up, right? Data aggregation is probably the one thing that nobody mentioned when we talk about technology in the classroom, but it is very important to educators. Is like, can you aggregate all the student data on how fast they're learning, where they're having trouble, what's going on? And if you can individually aggregate that data, that's so valuable to the educators, right? You talk about standardized testing, you can do it without teachers knowing, right? The data goes straight to the plug, which goes straight to the server. There's no room for teacher interference or any obfuscation of test results, right? So, content problem, that's one thing this solves. Power problem, so you can work. You remove the server router access point with one device. You don't need that big server, you don't need that router. You have it all built into one. All right, so this is the one that we're deploying specifically for education. It's called the Smile plug. There's two antennas here because it has an enterprise Wi-Fi inside, so you can serve 60 clients at the same time, right, 60 students. The junction server you were talking about earlier runs on the plug. Now you don't need a PC. So you have your server running here, so your teacher-student interactivity goes through this. Oh, you can build this for like $30. Okay, compared to the server. $30, I forgot to mention that, that's important. Okay. So then the idea is, can we get one of these in every classroom? Each classroom has a reliable cloud, has their micro cloud. Then it's all the use cases we talked about. The individual learning on the devices, teacher control, teacher sharing, student sharing, all the interactivity through here.
So we'll probably something that will say, what about
Okay. So today, what has been deployed is Junction Server, it's open source, running on this plug. The devices that have been used today are Android devices, Android phones and Android tablets. It doesn't have to be, right? That's just kind of been what people have been doing. So I think on the device side, it's less clear. different options can be working. Different options can work. Even PCs can work, right? PCs can talk to this. Everything talks to this via Wi-Fi, right? So far, in terms of what has been done, is we have, server running, we have basic admin, we have like the one junction quiz running together. But a lot of the use cases we're talking about have to be deployed, have to be implemented. And that's why here talking to you guys, what ideas do you guys have? What things can you guys implement? Right? When we talk to educators and we show them conceptually what this can do in the classroom, they get excited. And they get excited for different reasons because it solves different problems. For some people, it solves the control problem. For some people, it solves the content problem. For other people, it solves the reliability problem. Right? So, summary, what the Smile Plug does, it creates a reliable digital classroom. Right? You get a private cloud for up to 60 students. You can firewall, you can filter all internet access through here. Right? So now there's safety elements there. It can be a content server. It's easy, low-cost deployment. Teachers get this, they plug it in. We've made it easy. This means it's not working. Okay? There's a green smiley face when it is working. Right? So there's like, okay, it doesn't work, just you plug it in. Right? You have to make it easy for people to use. It's your access point, it's your gateway, it's your content server. It allows these devices to talk to each other. Talk to the teacher. Right? Finally, secure content. This means two things. One, you can secure additional content. This online content that people talked about. Two, the content is safe and it's secure. Right? It's like vetted. I mean, it's not just wild internet content. Right? People have a fear that if you give students devices, they're just going to go on the internet and find things they shouldn't find, at least in the classroom. With teacher control. Right? The teacher should be able to control the student devices through here. Everybody go to page 10. Okay? Or we're all going to, turn your device off. Or there's an element of control there. Okay? Yep.
How did you make it so cheap and so low power cost?
Really, fundamentally, it's Moore's law, as much as I like to say Marvell is smarter than everybody else, but it's really, technology has just evolved, right? The amount of functions we can put on a single chip is incredible. So in here we have one application processor, we have a Wi-Fi chip, we have some power chips, and that's it, right? Then it's just about how much flash do you put on. And flash is probably the biggest cost.
So the one last child, it was really hard for them to get that to $100. Is that screen or is it
So the most expensive cost in your consumer device today is your screen, your touch screen, your battery, and then like the mechanical stuff. Right, so this, minimal mechanicals, no touch screen, no display. In the case of $30, there's no battery. Put a battery on there, you get that battery cost. But the most expensive elements are not here.
so that you assume that people have those devices?
People have their devices, correct.
So like as far as individual devices, is it just like, having a web client, or is it right now like specific apps? And if it is specific apps and the devices that run those apps, how does that, compare the cost of having, possibly more expensive back end, but cheaper, individual devices too?
So there's a two-part question. So right now, I believe the server has certain API calls that you can use, and those are still being generated. It's open source. We're want to add more capabilities. So today on the Android devices, they're implemented as apps that are using those calls. It doesn't have to be an Android device. It could just be a lower cost device. To kind of half answer your cost question, one area where we see this lowering the cost is earlier we talked about that digital textbook, putting all the content on the student devices. If you put all the content on this device, then each student device doesn't need 16 gigs of flash or 32 gigs of flash. You can be very, very minimal, so you save your device cost. Now, I think the individual device costs today, even at $99, we talked about the price of technology, that's still an issue. Okay, in the US today, you basically have, I think, $80 per student per year to spend. But you get it every year. So for you MBA people, you do a rental model with service, $80 a year, you're good. Is there a question here?
So if you're pretty much just giving students 10 clients, then don't you have to issue them if they don't have opportunity for exploratory learning and kind of going out and learning things on their own.
So we're not saying limit that. We're saying in the classroom environment, it's a controlled environment. Right? If they have an Android device, let's say it's a full Android device, in the classroom environment, they can be locked down to this, and when they leave, it can be opened up.
But the classroom's the only place they have
Right.
access to
That's true. Then they're locked down. Then that's an administrative issue. Right? That gets into the people part. Do you want to let them have free reign to the internet and find things?
The developing world is the huge step forward. They
Mhm.
don't have access anywhere but in the
Yeah.
classroom.
It
Yeah.
occurs to me that it's easy to lock the devices to a particular gateway or a particular administrative domain, which matters, I think, really just that. Right? That in as much as the things are general device you can use outside the classroom, it's really don't be tempting applications.
Yeah, that's a good point.
Right? If you can lock
Yeah,
them,
and actually on that point, one thing I didn't mention, you make a very good point. And in some of these developing countries, like they don't let the students take their devices back, not just because of theft, but for their own safety. Like if they're walking around with this device, they will get robbed and mugged or whatever else may happen.
third-party theft everywhere.
Yes. So again, now you're bringing up all your issues. These are people issues, right? So how do you implement the technology? You know, what programs do you write that run on those devices versus this device is the whole infrastructure that can solve those problems? And to me, that's how you solve technology in the classroom.
And also, what is the Kang functionality of the junction server? What does it, like the open source server, what does it actually
So right now, it primarily works with this junction. Yeah, with these a couple of specific apps that run, the Junction Quiz, a few other programs. It really acts primarily for, where did my picture go? This. Right now it runs this teacher application that lets you see the different student devices and the questions. So in terms of room for this to grow, this is a huge area where we're looking for help. We're looking for more people to work on this, right? This is currently a Stanford open source program. We're talking to them about taking this Smile Plug, making it kind of a consortium or this group, so it's not just Stanford, because this is more than one school, right? And certainly this is as a project. I know this is a project-based class, right? What I would personally like to propose as potential projects, we'll get there actually. This is my main slide, the Classroom 3.0, we didn't even get here. So what I envision as the Classroom 3.0 is you have the Smile plugin here creating a microcloud in the classroom. It's easy to update. You can update via USB, you can update via the cloud, you can update via hard drive. You can imagine swappable hard drives. So every year I give you a new hard drive that has new data, you just plug it in. That's one way it can work. Easy to update, has a microcloud, has teacher and student devices. These don't have to be tablets, they could be phones, they could be tablets, they could be something new that hasn't been invented yet, right? But the key is they talk to the plug, they talk to each other. They control it, they can talk to each other. This controls access back to the cloud, the main point. And also in the classroom, you can have interactive whiteboards, you have interactive TVs, you can send content from here to these devices, right? It doesn't always have to be one-to-one. It can still be one-to-many, right? You can still have content here that is projected out that everybody can see, right? So this is the total classroom. So jumping into things that I think people could work on. There's certainly elements of the teacher-student interaction, right? Because there new apps for the students to, learn content that involves teacher interaction. Some of the things we talked about with individualized learning, right? Recognizing what they're good at, right? I could see people are taking a test and the teacher can see all the students' results and it's like, wow, he's on question 10 already, and over here they're struggling on question 2, right? Knowing that type of data. Teacher control of the classroom, right? Client-server models where the device issues commands to the student devices. What do you want to do? Everybody goes to this app, or everybody goes to this page? How deep does it go? Can I see your screen? Do you want to let teachers see their screen? right? Can they send messages directly that pop up and say, go back to reading, or do you want to do things like that? Content filter or aggregation, filtering content to the open web. How do you do that? Aggregation of content. I mean, we talked about some of those providers. Can you make this a Khan Academy box? I get all the Khan Academy stuff on here, or all the Berkeley webinars on here. Okay, we make that. Data aggregation, test results, standard tests, how students interact with their devices in real time. How much of that data can you capture? How much do you want to capture? So there's two parts. There's the capturing, and then there's the analytics. And this is big business. Okay, there's a lot of companies in there trying to do this analytics, right? But somebody has to get the data. If you can get individual data, that's worth a lot of money, right? It's like Facebook for like students. You know everybody's data. Server administration, how do you administer this? You don't have a display, right? How do you make this easy to administrate? For the teacher, for the server, can you do it remotely? Can somebody else here at Berkeley manage this server that's sitting in Rwanda? Oh. Update capabilities, right? How do you update it? How do you update it with new content? How do you update it with new servers? Interactive learning, individual learning. So these are maybe more on the device side. And then are there any ways to port existing content? So I mentioned earlier that this concept of the Classroom 3.0, we're targeting later this year to have pilot programs of this. Actually, pilot programs, mentioned earlier, relatively easy to get. People get very excited. So pilot programs in India, South America, Africa, of these new concepts. So anything we develop new, like a new junction quiz, right? A specific mobile app with content, we can go test it out in the field this year. Right? This is something that's here today. We can see how that works. Right? We would like to get concrete data back. Right? If it can be research data that goes back, hey, we deployed this in the field, 4 different locations in India, and they all came back and they all improved their reading scores by X. Right? That's very good.
When you say interactive TV, what do you mean by that? I mean, right now it's sort of hard to get TV and digital.
So it would be like I showed you that YouTube video. If I could just send it out to the TV, for example.
You mean is the TV as a monitor, or are you really talking about TV content?
Oh, I meant TV as a monitor. Oh. But TV content is certainly falls in that content bucket. Right.
Can these boxes deal with TV signals?
Not these boxes. You'll have to add a tuner. But there's a USB port. You can put a USB tuner. Right? Expandable. Like a PC, right? Can your PC deal with TVs today?
Not really, right?
Not really. But you can buy this USB tuner and then it can. Right? So it's the same type of thing. Right? This is a PC. Right? Don't forget it's PC. Okay, so that is, you'll have this. These are just some links. Dr. Kim at Stanford University is the guy who went on those trips. So that's his pictures. But I guess we'll go back to this. So this is, a lot of the technical details are on those links. And in follow-ups, we can help provide those. Go to plugcomputer.org. Has links to that. Certainly you can send me emails. We have a lot more stuff. I didn't really cover the technical stuff today because that's not the issue. Right, to me, that's not the issue. So, any questions?
Perhaps getting more to the people side of things, which you've alluded to. You've mentioned that the market is very fragmented because it's just technology things, but in a lot of ways the offerings are very fragmented.
Correct.
You've got a lot of competitors doing sometimes overlapping things, sometimes not. And while people are really excited about technology in the classroom and excited to pilot at first, there's always that innovation fatigue.
Mm-hmm.
So what are some of your thoughts around how or other companies have been thoughtful about rolling that out in a way where it captures that excitement but doesn't it doesn't almost just abuse that experience
Right,
and,
right.
and have things
Yeah.
remove the reliability
Mhm.
wise otherwise you
Yeah.
know, in the classroom and that's moving that back.
Right. So I think it's a good question. I think part of it is the content that you're deploying has to be very high quality. You're delivering something that is a value that's like they couldn't get otherwise, right, from a content side. And then the other part I think that's needed to move forward that I'd like to see is you need kind of the academia side to verify that this technology is actually working. Because if companies just do it and say, well, this thing works, there's that commercial aspect to it where people are like, wow, they're just pushing their own product, right? They're just trying to sell, more PCs. They're just trying to sell more plugs. They're just trying to sell more of this. So I think this is where academia has a role to play. One, in that you guys have this high quality content. And two, you have that sort of independence from the commercial aspect to where you can really look at it, did this work, right? Did this actually help improve, right? And I think if you start, the innovation fatigue happens when people don't know it's working, they don't see tangible results. So if you can prove that, if you can show that, and it's not going to happen overnight, right? You go from one pilot in one classroom to a pilot in 10 classrooms to maybe in one district, right? It's going to take time, and technology will look different 5 years from now than today. But certainly that's part of the challenge why it hasn't really taken off, right?
Any other questions?
The question is bandwidth limitation. So far, do you have the 60 students can support by that small box, especially video streaming, for example?
Yes. So the use cases, it depends on, like video streaming, depends on broadcast models versus individual sending. But the Wi-Fi we're putting in here is 4x4 enterprise grade Wi-Fi. It's the ones that are used, at those airports, the Cisco enterprise routers. It's a heavy duty Wi-Fi. I mean, it's the best there is commercially, right? So, of course, there's still limitations to that. But in terms of, we're not limiting it. This is the newest technology that exists today. So I think the use cases do need to be evaluated in that context. Right.
Suppose I'm running a school that already has reliable Wi-Fi. Let's pretend Berkeley is such a school.
Okay.
We're not quite there yet.
Okay.
Would I want to have these boxes, or would I do everything centrally in a university data center?
Come.
I feel like the latency between my laptop and a box in the classroom versus my laptop and a server in Warren Hall is not very big.
I would argue from a technical perspective, see a reliable Wi-Fi, it doesn't make a difference. Okay, but from a people perspective, the cloud is a mystery. To a teacher, this device, they know it's there. It has a frowny face. Oh, it broke. I'm going to go back to paper. Right? I can unplug it. I know I have new content. I stick it in. There's a user element aspect that I agree doesn't have to be there if we're looking at it from a pure technology perspective.
I think this is really great to solve not the university higher education problem, but the K-12 and developing world problem, especially a lot of developing world stuff that I've read about. And I think it's really exciting and really cool. I'd say the one thing that it doesn't solve in your early list is the teacher anxiety, some degree of how do I teach with this, except for getting rid of that it doesn't work thing. So I was wondering, and I also didn't see that so much in your list, surprisingly, this class. So I was wondering what you're thinking about that.
So I think it addresses the elements, it potentially addresses elements of teacher control of the student devices because there's that interactivity from the teacher to the student. I fully agree that it has not solved the content problem where I'm used to this worksheet. Now what am I teaching off of? Right, so I don't think that is solved alone by this. So that's a separate challenge, right? That was kind of the last, is there ways to port existing content?
I think I meant the anxiety problem of if there's
Yep. You have to make the teacher device easy enough for them to use that they don't feel dumb. And that's not a great answer, but that's I have to worry. Yeah. That's actually a problem for you guys to solve, right? Hopefully. Make a teacher device easy enough for all teachers to use.
My feeling is that the typical use cases involve having a set of predefined content being taught in the classroom, not something customized by the teacher. Otherwise, I mean, that porting existing content doesn't really make much sense, right? Porting existing content is so that basically every classroom has the same content that has been ported. Is that the case? So,
well, sorry to cut you off. I think there's two parts to it where a lot of teachers, at least that I've talked to, like in the Bay Area, they do develop their own content. And teachers often share content with other teachers. So this is another aspect of if you could help them share their good content with others, there's an element of teacher-created content that's individualized. And there's a part of the standard content that's like you must cover these subjects in these ways. So I think both types of content do need to be addressed. And maybe it's less of an issue in developing areas where there is no existing content, and they're saying, hey, if you give me great curriculum or you give me something new because I have not developed it already, it's easier for them to just take.
Okay, so the follow-up. Actually, I think that I was thinking more in developing areas that having something that is very standardized might be difficult because, you know, maybe you'll have a classroom of 10-year-olds that are struggling to read, and then in another place you'll have a class of 10-year-olds that are struggling, you know, to do some math, you know, because there can be a lot of differences in different places. And I was thinking how a professor or a teacher would customize content, right, if they meant so, and that is also something that I'm not sure working on, like you don't want a teacher to be a developer, right?
Right. So actually that's a great point, right? If you could make it so that it's very easy for the teacher to develop their content in this digital system, then they'll develop content for the digital system, right? Because today teachers, they create a worksheet, they'll create a PowerPoint, right? What's the next level, right? We talk about this interactive learning. Could they create an interactive lesson that runs on the student device, right? And maybe that has nothing to do with this micro cloud or anything else, but it's about teacher tools. Maybe that's another area that, there you go. There you go.
The other thing about content you didn't mention is it could make it easier to legally take care of the intellectual property, right? Sort of package.
Yeah. That's why I said it was secure content. And then two things in secure.
Secure is different than, I mean, I can imagine bundling running with these machines.
Yeah, well, I can imagine, again, this is not because of technology, but this could be your 5th grade math plug. And then you have a separate one. That's your 5th grade science plug. Right? Even though they can be on the same plug, but it's just easier to be like, okay, well now I'm just switching from science to the other one. Change it out. Right? I could easily imagine that. Oh. So somebody does this project.